Longest valid parentheses, you get a string of parentheses. Return the length of the longest contiguous balanced substring. Example 1, S is open, open, close, the longest valid piece has length 2, for example the two characters at indices 1 and 2. Example 2, the string starts with a closing paren, then has a longest balanced block of length 4, for example open close in the middle. The most common solution uses a stack. We push the index of every opening parenthesis, and when we see a closing parenthesis we pop and pair. That gives the length of each matched segment. It is reliable and linear time, but the stack uses order n extra space for the indices. We can ask for constant extra memory besides a few counters. To get there, we stop storing every index and instead think in terms of balance between opens and closes as we scan. Scan left to right. Increment left when you see an open parenthesis and increment right when you see a close. Whenever the two counts are equal, the scan prefix is perfectly balanced, and its length is left plus right. If the close count ever exceeds the open count, the prefix has more closing than opening brackets, so it can never be part of a balanced substring starting from where we last reset. Set both counters back to 0 and continue. One forward pass can finish with extra opening brackets, so the counts never equal and an inner valid pair is easy to miss. Run the same counting idea from right to left, but reset when opens exceed closes. 2 linear passes, only a handful of integers, no stack. This is the forward loop you would type in after the intuition, 1 index I, 2 counters, and an integer max. Each step moves the beam and updates left and right from the character. We are not rederiving the idea, we are watching the bookkeeping. Whenever left equals right, treat that prefix length as twice right and fold it into max with max equals max of max and twice right. In the same forward loop, the reset line runs after the updates. String open close is different from the 2-character example in intuition. After open close the counts match, so max takes length 2, then the third character is an extra close, right overtakes left, and the if block clears both counters before we would extend a bad prefix. This longer example is about the forward loop's update rule, not the high-level picture again. We only write to max when left equals right, so after the opening pair you see max jump to 2, linger on that update, it is the only time max moves in this whole walk. By the end the running counts are 5 and 4, they never equal on that tail, so this single pass never promotes max past 2 even though a longer valid substring exists elsewhere. That is exactly why we add a second loop instead of arguing it in prose. Now the implementation detail intuition only hinted at, a second loop with the index running backward. Reuse left and right, 0 them when left exceeds right, and on equality fold twice left into the same max variable. The scan is deliberately slow, whenever max increases, stay with that frame, the backward pass is proving the full length. You are watching the symmetric branch of the program, not rehashing why 2 passes exist. N is the length of the input string. Time is O of n, we scan S twice from end to end and do constant work at each index. Space is O of 1, we only keep a few counters and the answer, with no stack and no extra array proportional to n. Pseudocode for longest valid parentheses using 2 passes and 2 counters. First walk left to right with a reset when closes exceed opens, then walk right to left with the symmetric reset when opens exceed closes. Set the running best length to 0. Set left to 0 before the forward scan. Set right to 0 before the forward scan. Forward pass, loop I from 0 through len of s-1. If the current character is an open parenthesis, increment left. Otherwise increment right for a closing parenthesis. If left equals right, update max with twice right. If right exceeds left, reset both counters to 0. Clear left again before the backward pass. Clear right again before the backward pass. Backward pass, loop I from len of s-1 down to 0. On an open parenthesis, increment left. On a close, increment right. If left equals right, update max with twice left. If left exceeds right, reset both counters to 0. Return max.